Good morning, everybody. So, my name's Thomas. Some of you might know me. Some of you have seen me around. I've been in this industry for nice shy of 30 plus years. I started security about 25 years ago. And one of the things that I've done is I've literally grown my career both through end user organizations, consulting organizations, and software organizations. Currently, I basically work for myself, but I work for people that I know, for companies that I have contacts in, and I help them with different subjects, ranging from compliance all the way to incident response. And one of the peculiarities I have is I tend to focus on the aspects of protecting the critical assets, right? And for me, a critical asset nowadays, especially in Europe, is all about data protection, unfortunately. No, I'm not going to talk about GDPR. Actually, I might, but for a different reason than you might think. I run B-Sides London, for those of you who don't know me. But I also actively share in other organizations, and I'm the VP of Data Governance for the ISSA UK chapter. So that's a quick introduction to myself. Now, if we go back to part of my activity, which is incident response, I go into organizations sometimes to help the incident response teams, or to help the CERT teams, or to help some of the analysts go through some of their incident response. And one of the things that we start doing is searching for the machines, right? So we're going all through these machines. We keep going through the machines. We get to a site or to a particular set of machines, and there's no freaking tooling on it, okay? I'd like to apologize, but sometimes I throw in swear words when I'm speaking. I hope you don't mind. It slips out. So you've got no tooling on these machines, and you're sitting here going, oh, crap, now what do I do? And you find yourself banging your head on the wall, because on one side, you don't want to have to forensically image every freaking machine that you found. And I've been in situations where, like, there's a mountain of machines to go through that have been imaged, and that means your incident response scale is going from a few weeks to freaking months. And like, why would you even do that to yourself? I really feel sorry for the Norse guys right now. They are going to have a shitload of problems. So I'm sitting here banging my head against the wall, and I'm like thinking, well, how can I actually get around this, right? I don't want to install any tools because I don't want to mess up the machines. I don't want to have to reboot the machines if I have to install tools and things like that. And I'm sitting here going, well, I need something that's not intrusive, right? I need something that I can basically, when I hit a machine or when I hit a site, I can just use. Quick and easy to use, deploy, no deployment possible, minimal cost. So it's got to be something that's either open source free or just there, right? And I'm sitting here going, it's like, well, you know, I do a little bit of admin for systems, things like that, and hold on a second. I could also use this to do, if it's the right tool, I could use it to do dynamic investigations. So I could go in, start to look for things, or I could even go hunting. Threat hunting is one of my little side projects, and I kind of have some big rants on threat hunting. You can catch me later if you want to talk about them. And I'm sitting here going, wait a minute. I hit majority Windows 7 to Windows 10 machines and Windows servers. There's a freaking really useful tool on those machines, Powershell. I'm like, PowerShell is so great. I mean, just like you've got everything that you really need in PowerShell. You know, it's like if you've never used PowerShell, just go and play with it for a while. You'll never want to leave it. I mean, I'm almost on the point of starting a hashtag Python sucks, PowerShell rocks, because you can do things a lot easier in PowerShell than you can do in Python. And I'm sure Carlos Perez is giving the PowerShell training. He'd probably more or less agree with me. So why PowerShell? Well, you have built-in regex support. So you can actually do searches, and you can actually configure finds inside your data blobs with a regex. So you can do things like pull out event logs, and you can match usernames and domains, and you can quickly, easily find information that way. So you could find if an admin user has been logged on or was denied logon and things like that. You've got built-in functionality. So I just mentioned you can go into the event log, but you can actually CD into the registry. So you can navigate the registry as if you were navigating the registry with a command line, right? So cd hklm, then you have access to your whole local key machine. And you can search that local key machine. And you can make changes to it too. So that's kind of useful. And you can also pull out property machines from WMI. So there's a lot of stuff that you can do. Now, once you've done that, you can then place your information in objects. So a variable can be defined as an object. So once you define that variable as an object, you essentially have the equivalent of, if you use JSON, you essentially have the equivalent of a JSON blob, or you have simple things like, here, I can get the ACL of a path, so local path, and I can show the owner. So everything is an object. So this basically what this does is it says, get me the access control list of the root directory and show me the owner, right? So this is like heaven. I could just go in, open a PowerShell command, and I can start digging into the machine, right? So I'm thinking, okay, let's go through this journey. Let's see how far we can push this. Wait a second. If I want to push this, I'm going to have to write a script, and I'm going to have to download that script to the disk. Damn, that breaks my one thing. If I don't want to do is change the disk or add stuff. But hold on a minute. I do a lot of threat hunting. Can anybody tell me what the really recent techniques have been in most of the phishing email attacks? What do most of the phishing email attacks do? Exactly. But downloading where? Not to disk, direct to memory, right? So I said, well, hackers can do it. Why can't I? If I publish my scripts on a local drive shared across the organization, or even if I publish them on a private website, I can just use a command like this, pull my script into memory, execute it, and I have my functions. So I'm like, yes, I can do this. This is really great. So I've got everything that I really need. So I start to dig into it a little bit deeper. So I've got an awesome start, right? I've got registries, event logs, file system. I can even pull local firewalls if the firewalls are implemented. It runs in memory, so no disk changes. I also have methods of actually pushing, because in the same way that you can download, you can actually do a network connection and push information up into a cloud application or into a local web store or something like that. It's generally available on Windows 7 or greater, and you have lots of cool useful scripts out there. So do you? Yes, you do. There's a site run by, there's Posh, there's a whole bunch of people working on it, there's a whole bunch of stuff in Git. The PowerShell core, the new version of PowerShell, is actually it has been open source, so you can actually download it, and you can install it on literally basically every system out there nowadays, because they've made it universal as well. So you can use it on a daily basis, and you can replace it for most shells. So I started digging, and Jared Atkinson developed this framework called InvokeIR, which is PowerShell Forensics. It's a really good tool. It gives you everything that you need to essentially do disk-based forensics. And you can pull out really good stuff like alternate data streams, event logs, prefetch, recent file cache. But when I look at it, and I start playing with it, you need to deploy a DLL. So I was like, oh no. But then I said, hold on a second. Let me go grab a drink and I'll think about this. Right? So you remember that hacking command? It doesn't have to be a script. I can pull up any binary. I can take that DLL, dump it into base64, put it into a variable in my script, load that variable in my script, and run it in memory. Yes! So I have my foundations. I've got PowerShell. I can write my scripts. I've got built-in access to things that are really important, like registries and objects and regexes. I can pull in scripts from other people as well. So I can start on my mission, which is basically to do initial investigation on forensics and a little bit of hunting. This is great. So I'm digging through this. So how many of you do a lot of forensics in here? Okay, so how many of you actually use the system resource usage database? So SRUM is essentially the Windows System Resource Usage Monitor. There's a really good paper that was published by Yogesh Kothari, and it was also published in SANS. There's been some people who've done work on it since, Mike Baggett, I'll get to that in a bit. But essentially what it does, it's been on Windows since Windows 8, and what it does is it provides telemetry on process and network monitoring. If you look at your Windows services, it's called the Diagnostic Policy Service. And it's continuously monitoring and storing data on the applications, the processes, and power consumption, things like that. So you have all of this data in the machine and how the machine works. And I'm like, this could be really useful, actually. So I read when I was reading the paper, and I was like thinking about this, and how do you do this, right? So how can you access this? The paper goes into it. So what I'm really interested in is really these two things, right? If you're doing forensics, two things that you want to know really is what applications have been running and potentially what network activity has been happening, right? So that's really interesting for me, especially to initiate that investigation and say, okay, this machine looks interesting. I need to do further, deeper forensics. So what is in SRUM? So SRUM essentially has 5 core components. There's a few more since Windows 10 and Server 2012. So you've got application resource usage. So basically what that one says is, it monitors all the applications, what it's using in terms of network, what it's using in terms of power consumption, and how long it's been running, and things like that. Windows push notifications, as it sounds, it's like when Windows is pushing you information, so when Windows reports information to you, things like a crash. Energy usage, so that's literally energy usage, right? So we're talking about how much power the operating system is drawing, how much power an application is drawing, and things like that. The network connectivity, this is actually really interesting. So basically what it does is it looks at all of the network connections that are being created or torn down on the machine, right? So it actually tells you when your laptop is connecting to a Wi-Fi connection. And it'll tell you which SSID, you'll be able to dig out which SSID it was connected to. It'll tell you if a VPN service provider network interface has been created. Network data usage, that maps how much read and write network activity is happening per application. And that could be very useful if you want to, say, detect something like Explorer doing a lot of file uploads somewhere, or doing a lot of exfiltration. So network, but what it provides is an interface type and ID, a network profile ID. So if you think about in your Windows networking stack, you have essentially the interface ID, which might be an Ethernet 1, Ethernet 2, and then you have your network profile ID, which might be home network, work network, your domain name, because most of the domain names become the network. You've got the bytes uploaded and downloaded, process consuming the data, and it includes the user SSID. Really? Oh, that's interesting. Because if I have network activity plus application plus user ID, I could look if it's a non-standard user trying to upload stuff or pushing network activity. Interesting. Unfortunately, it doesn't have endpoint IP address ports, and it doesn't have specific network activity. So you won't be able to pull out Explorer going to FTP:888.888, right? So you won't be able to get that kind of level of detail, but you get enough detail to understand which applications and which users are doing the most network activity. And you could build, because you can pull it out over time, you can start to look at building graphics. That's more deeper into forensics. So the application that provides is number of CPU cycles, number of context switches, I/O reads writes, number of read operations, number of write operations, number of flushes, so everything that has to do with application memory management. The user information includes the SID of the user that launched the application. So, one of our favorite attacker techniques is to basically install a backdoor user. You get that backdoor user and you start running applications, or you try to escalate admin using Benjamin's tools. You get an admin password, you get into the, and you start an admin process, right? So you can actually see this because you've got the SSID that's actually launching the application. It doesn't have memory information, so you don't have access to the memory. This is what I want is an initial investigation. I'm not that concerned with the memory, right? If I need to do the memory, then I'll do the proper imaging. But I want to understand if anything's happened on that machine before I do that. So application history, so if you look in your Windows 10, and you go to Task Manager, you go to Advanced, there's an extra tab called Application History. And what it basically does is it shows you all these applications, the time it's run, the network usage, but you can also show history for all processes. What that does is it actually shows you what processes or applications have been created and deleted. Because the deleted applications will still show in this list. They'll just show up as deleted. Or I think it says uninstalled to be precise. So those applications were run, but are no longer available on disk. So if you have a user that's installing illegitimate software, that potentially allows you to actually see it. So how does it work? So essentially, the Diagnostic Policy Service uses 5 DLLs, that control what it's gathering. So between network, push notifications, and application activity. It stores it temporarily into the registry and then dumps it to disk. So that dump happens every 60 minutes. So you can actually go into the registry, you can see the SHRM extensions, and all those IDs are basically the DLLs that are used by Diagnostic Policy Services to do its work. And as I said, every 60 minutes, I will get through this. You dump to disk. So I'm like, okay, this is cool. So the database on disk is in C Windows System 32, SRU, srudb.dat. It's an extensible storage engine. So if you're working with AD, if you've worked with Windows Updates, Windows Search, ESS is one of the key things that you need to learn in forensics when you're doing Windows forensics, because a lot of information is stored in these types of databases. I'm not going to go much into the extensible storage engine. I hate the damn thing. It's a fucking pain in the ass to use. You have tables. The tables are based on your DLLs. So the original tables were just these. So the table name is this horrible ID, which is a real pain in the ass to use. And I have a description on the side. So the first one, network connectivity data. Then you have the application resource usage data. You have the network usage data. You have the Windows push notification data. You have energy usage data. And you've got two. So the LT on this one means long term. Oh, that's interesting. So that means you're storing energy consumption over long-term periods of times as well. So this could be quite useful. There is a documentation project at this URL. I'll release the slides afterwards anyway, so it's long and complicated. But if you look up libyal ESDB, you should probably find it. It's on GitHub. So he started documenting some of this stuff. So what's in the tables? Well, the network usage monitor is pretty simple. You've got an auto increment ID. That's a database, right? So you need an ID. You've got a timestamp. Cool. That's cool. You've got an app ID. You've got an interface LU ID. You've got an L2 profile ID. Okay, so wait a second. These are all IDs. Where do I find the actual information? So for the L2 profile, I need to actually pull stuff from registry. The app ID and user ID points to a database in the SHRMDB called shrewdb ID map table. We'll get to that one later. What really caught my eye is that, wait a minute, timestamp? Really? Multiple different versions? Or can't you just stick with one? So I haven't figured this one out yet, but essentially it's a 64-bit value, so you can just convert it into time. And I'm not really concerned on exact times. I just want to know rough times, because initial investigation again, right? So useful. This is the application resource usage. So this is some of the interesting stuff, right? So you've got the same problems of IDs, pulling stuff off the date, but you've got things like it's telling you how much time is spent in the foreground, how much time is spent in the background, how much face time the application has, so face time, I think, and I'm not sure because this is not documented, right? It's how much time has been used, the application has actually been used by the user. Versus a foreground cycle time, which is the application is running in the foreground. That means it's got the foreground CPU cycles. You got the context switches, and then you've got some really interesting information on reads and writes. So if you're dumping data, you're going to see a lot of writes, for example. So that could be, this is all information that you could be useful, right? You can think about how you can use it, extrapolate this information to understand what a process is doing. The ShrubDB ID. So this one's really simple until you get to the ID blob. Large binary data plus. And when you actually look at what the ID type indicates, so you've got 4 values for the ID type, 0, 1, 2, and 3, that actually defines what's in the ID blob. Okay, this is getting complicated. So if you have a value of 0, you've got an application path, UTF-16 encoded string. You got, I think, ID 1 is services. At least it looks like service definitions. ID 2 looks like MS apps, you know, the ones you download from the Windows Store, the ones that you see in Cortana and Windows 10. The service subprocess is, so if you look at a service in Windows 10, you have the service framework, and then you can actually launch services within that framework. So the service subprocess seems to be those sub DLLs that you're launching in the service framework. And then you have the SID as an ID blob. So it's actually not even in clear text. So basically what you have to do is you have to convert that SID back into, well, the blob into an SID. So the interface LUID is one of my pains right now because it's essentially defined as this in code. So you have to pull out the information to then extract the strings, but also extract the registry ID so that you can go back into the registry and look for the actual interface definition. So it's not a lot of fun. So what's the forensics angle on this, right? So how do we do this? How do we get access to this information? Well, if you think about what this is providing, we have a process map, right? We can build a process map. Because we have the ID and the processes that are being launched, we know who launched what. So we can see who launched what. And more importantly, we can see who launched what when. So if you have a bunch of systems that are in office and you start to see applications being launched at 3 o'clock in the morning, you know, the classic scenario, that machine's probably being compromised. I've actually been in situations where they've had to go back and look at the CCTV to make sure that there was nobody at 3 o'clock in the morning, which is always fun. You have the network statistics where you understand how much data is being written and from what processed onto the network. You've got program tracking, find those deleted apps. Process runtimes, you know how long the process has been running, right? Most users will run the apps, most normal users will run an app and kill it, right? And, well, exit it. If you see an app that's running for like 7 or 8 days in a row on a standard user machine, it's probably something wrong because normally that doesn't happen. But then you add usage, energy usage. And I actually wrote this before the Norsk incident. And I'm thinking, hold on a second, if I can see how much energy a process is pulling, could we actually backtrack this to understanding if there's some kind of crypto miner or some kind of ransomware happening via one of these processes? I'm thinking more, the Java side injections of crypto miners, which is always interesting because you also want to understand performance, right? So one of the things that this does actually provide is better runtime processing mapping. If you think about your traditional forensics in Windows, when you're looking at when a process has been launched, you typically look at the prefetch information, right? So, I mean, if the guys who've done Windows forensics in here, you're probably shaking your head, right? First thing you go for is dump the prefetch, right? So, but the problem is the prefetch is it only shows you the start time. It doesn't show you how long the process has been running. And plus, it's easy to mess with as an attacker. Shrum adds a lot more visibility because we're continuously taking benchmarks on the data, right? So as we have the complete picture, we can actually map how long the application has actually been running, not just when it started, right? So we got the start time and the known duration. So that's useful. So the other useful stuff is we map the processes of the user, we map process with network activity, potentially understanding whether we've got data exfiltration, and we have general process usage investigation. So just understanding what's being running on machines. I used to work in the oil and gas industry. This was the fucking hate of my life, okay? Having to actually dig through the machines because somebody ran something they shouldn't have and showed it to somebody else. That's why some people like to call instant response indecent response, indecency response. Yes, I threw it in for somebody. Shub data. It's admin lock. Oh, crap. Mark Baggett's tool and the work done by the original researcher uses a lib scdb to dump the ESC to SCV. So again, back to my problem is that I don't want to install anything. I don't want to have to do forensics. The Shrum dump tool from Mark Baggett actually requires a copy of the file. So there's multiple ways of getting that copy. You can do a VSS or you do a disk image, right? I don't want to do that. I want to do it online. Yes, I'm a spoiled brat. I've been in this industry too long to actually waste my time pulling images all the time. So all I want really is a copy of the DB without having to fucking image it, or access to that DB without having to fucking image it. So banging my head against the desk again. There's got to be a better way to do this. I need to be able to do this. I want to do this. I'm like so attracted by this data by now, right? It's like this data is really useful. Oh, a second. What are we talking about? I have a solution. It's called Powershell. Does anybody know why I can use Powershell to do this? Remember I mentioned advanced capabilities? I can load DLLs with PowerShell. But better yet, I can support .NET PowerShell DLLs. So I can actually run .NET libraries and APIs in PowerShell. Cool. This is PowerShell 6 running on my Pixelbook. So there is actually a PowerShell module, a .NET module to access these databases, the ESC databases. The reason is that Windows uses a lot of it, so they have to have a mechanism to access that database. So it's called the ISM ESVNT Interop DL API. It's available in Microsoft version 4.0. Does anybody know why that's important? Find me a Windows machine without version 4.0 installed nowadays. So this is there. This DLL is there. I don't have to touch the disk. It's already on my disk, right? I have access to it. So I can just load it. It's like, yes, we can do this now, right? So I'm going to do, so I was hoping to get further into building some scripts and releasing them today. Unfortunately, real world doesn't like me. And running B-Sides London is a nice task, but it can take a long time as well. So, what I'll do is, so I tend to, when I'm coding, when I'm developing, what I tend to do is I like to basically step through my lines, especially in PowerShell. One of the advantages of using PowerShell is you can actually, before you write any code, before you write any script, you can test your commands. It's pretty simple. You can do them on the command line. You can do them via the IAC. So the IAC is the integrated script editor, and we'll see that in a bit for those of you who don't know it. So basically what I'm doing here is at the top, I'm just setting a variable to the path of that DLL. What's nice is you can reference back down into environment system variables. So the $env just tells PowerShell to go look for the system, for the environment variables, the standard environment variables, and pull out system root. I set the path to my database. So this command, add type path $ESEnter-DLL path, that's going to load my ESE API into memory. So I now have a .NET library loaded into my PowerShell session. So the first thing you need to do with these types of databases, because they're jet databases, you need to you need to gain access to the database, right? It's really hard. So essentially, the first thing you need to do is get info about your database. And that you need the file type, the page size, and the DB type. Because you're going to need those parameters to actually open your instance and open your database. So what I'm doing with these next commands is essentially I'm telling the API that I want to get the file type and page size by giving them a default value. And then this is how you access a .NET API in PowerShell. So basically, you reference the API, the .NET API in hooks, and then the function in that .NET API with double colons, and then you give the parameters. And depending on the function, you have to pass a reference to your variable because the variable is going to get updated within that function, right? Or you have to assign it to a variable depending on the output. So if you like line 12, you see that I'm actually, once I have the file type, to get the database type, I'm just pulling out the database type. So we do that. Then next, we have to open a jet session. Jet session, you have to create an instance. You have to create a session ID. And you have to pull out all the information about the database. That's what all these temp things are. So you basically look at page sizes, recovery, circular logging. If you're managing the database properly, you need to understand all this because there's logging activities, recovery. The database might be in a failed state or in a temporary state. But I don't really care about that because all I want to do is really access the data in its raw form and dump it out. You then create your instance, you initialize your instance, and you can begin your session. I still don't have access to the database yet. Okay? I've just created a session to create a database. So if you think, MS SQL, when you're trying to access an MS SQL server, you have to first create a session before you can get access to the database. Same principle, right? Now you can actually get to the database. So you can connect to that database with this line. You attach to the database. You open the database. I now have a session with the database. All right? So we can check that out. We can check that this information is there. That was my coding. So down here, I don't know if you can see it too well. Maybe if I'll take off the, yeah. So this is the original tables that I showed you, right? This you'll see on Windows 8 mostly. This is the Windows 10 definition. You'll notice there's a couple of extra databases in there. It's like, oh, great. To figure out what those are because they're new and they're not documented, of course. So next step to access the information is to understand the columns. Because, of course, it's not like SQL query that you can do. Essentially, when you're accessing these databases, you have to literally go column by column, row by row. It's horrible, okay? So first step is you need to understand what columns are available in the database. And this basically, what I'm doing here is I'm going to access this table. I create a new object. So creating a new object basically provides me with the ability to actually create a session to that table. And then I can just get get table column names. I'm skipping the API parts because most of them are just gibberish anyway. You just have to figure out which ones are relevant. The API is actually really well documented. The contents of the databases is shit. So here, basically what I've done is I'm using my session, and I have the table jet ID, which is the ID that's provided to me from accessing the table. So that's actually in this table variable. So I can I can attach to multiple tables at the same time. Well, that's good. So now I've attached a table. I know what columns there are. I want to extract the data and put it into a PowerShell variable. So what I do is I basically create a new table. So that new table, I'm giving it, because I don't want to lose the reference, I'm putting the table name, and I'm assigning it to the tag, to the label name. I'm assigning the label ID, assigning the table ID in case I need to re-reference it, and I'm inciting another PowerShell object inside that object called rows, where I'm going to put my row information. So I dump my columns, and now I have to go through this. So each column essentially has an ID and a column type. That column type determines the value of the data blob for that column. So basically, you have to build a case statement or a switch statement, as they call it in PowerShell, to actually go through each ID type and then dump the value that's stored for that column. So as you can see, some of them have constants already defined in the API, right? So you've got long text, text, long binary, binary, long binary, IEEE single. And then you get down, and you get down, and then you find a value 15. Okay, API, no definition. So, okay, it says it's a date timestamp. So fine, 15 is the date timestamp. We'll go for that. So because we know that it's an int64 date timestamp, I retrieve the column as int64, and then I just do some conversions of that int64 into a date time. And there's always the case where, oh crap, didn't get access. So it didn't match any column type. And then, so now I have a column name and a value. I can just add this as a member to my rows variable, right? So then this next line, we just move through each row, through the table. And then, of course, you have to shut down. You don't want to leave a database open. You never know what's going to happen. It's like, cool. So I do have a demo, but last time I tried to do the demo, it went totally bonkers because I have to do it remotely, so you never know. So I've got my walkthrough. So I'm going to do my walkthrough. So first I load my variables, I load my DLL. So this is the power of using ISC when you're testing and building, is you can put your script up here, and you can go row by row and just execute the highlighted section, and you can see what works and what doesn't work. That's the way I do it. I mean, I used to be a developer. I don't do it anymore. My son is becoming a developer. I don't have the patience anymore to actually develop proper code. Oh, wait a minute, something went wrong. Oh, crap. Using the wrong user. So if you look here, I've basically been told that I cannot access the file. File is logged to in use. I wasn't in the right user account. So this provides another problem to me, is I'm going to have to somehow figure out how to do privilege escalation when I write the final script, right? Because I need to be an admin. Because there I was just a normal user. Come on. No, I don't want to repeat this. Okay, so, hey, I have access to the machine. I think Benjamin, he was an admin on his machine. I can be admin on my machine as well, right? Because I have access to the machine. So I run PowerShell as admin. So now so the difference here is I have administrator in the PowerShell. You'll see that my default path is system 32. I run ISC. I can still run ISC in PowerShell. I can load up my scripts for this testing purpose. Give it a sec. Problem is, Google Slides is really good, but I haven't figured out how to fast forward videos in it yet. So I am a bit lazy, so I actually took that whole blob of that whole switch statement and put it into a function. So basically, I'm going to do the same thing. I run that, add my DLL. So now I'm going to get access to the database. Well, create the session. So I'm just checking the values. Okay, so DB type database, this is important. This is another great feature is that it basically auto-completes. But having that database type is something that I can check on that I'm on the right file, right? And the file type also will tell me it's 1. So I can use this value here to check that I'm on the right file and I've got a proper session preparation. And this gives me the page size. So if you remember at the beginning, I set the page size to -1. So I know that I'm accessing something and I have access. So now I'm going to do the open the jet session. So I'm just going to copy everything and run everything in one go. Same thing, I'm going to check the variables that I created, the session variable. So this is important, right? So when I just dump session, it tells me is invalid false. And this is all confusing because, you think, oh, false, that means I don't have a session. But read the column title, is invalid. So if you don't have a session, that's actually true, right? So I know I have my session. This is great. I know I have my session, so now I can access the database. And I can see the instance as well, which is also saying false, which is good. So now I'm going to attach myself to the database and open it. So I've attached myself to the database, so I have a database ID for this session. My session is still false, so my connection is still there. And $connect gives me nothing, which is good because it's not being used anyway. So now I can actually access the tables. So here you see that I've just got get new table names, so I can see the table names. There's that shrubDB ID map table that I was talking about earlier. So now I'm going to create table references to be able to use in my script later. So I'm going to open the tables. Oh, go back. So when I'm opening the tables, I'm also dumping. I do a write output. That write output basically tells it to dump the columns. So you see here the columns that we have. So number one, you'll see that they don't come sorted. Of course not. Then you have a column type. See the 15 I was talking about earlier. The length. So 4 is the standard. 8 is a 64-bit, 64-bit. And then you've got column fixed or column order. Those are the types of columns. So if you know database, it's pretty standard. There's the application one. Well, that's the network one. Network usage one. This is the application usage one next. So yeah, there you have the same tables I showed in the slide. So we have access to this database. Cool. Okay, great. So I have access to the database. So I don't want to go through all this freaking code each time. So I put that code into a function. There's one flaw in this function. Let's see if anybody notices it. So the function will pass the table reference and then just go through the row, right? Go through the rows. So that's, by doing that, I now have a function in memory, right? So it's right there. So you'll notice that essentially it says you also get, if you coded your function properly, you get the reference to what parameters are needed for the function. Okay, so now I can go back to my table. So I do a table DB ID first. And this is where I'm still working on is actually, because I have 3 different values for the blobs, I need to go back and actually look at the dumping of that table to fix the blob and pull out the proper string and pull out the SID, right? So I can do, so there I just dumped it directly. If I assign my function to a variable, I will now have it in a variable. And I can do some cool things with it. We'll show you later, but I can format it as a table so we can see the data a little bit better. So you see now I have the index value, the type, and the value, and the actual blob value, right? So that's the power of, that's kind of like simple power of PowerShell when you get down to it. So let's dump that new table. So this new table, this is one of the new tables in Windows 10, but I don't really understand what's in it. This takes a while because there's a lot of information in it. It was a good 10 minutes, I think. And I shortened it in the video. Okay, come on. So now I can dump the table. So you see there's a whole bunch of IDs here. There's a whole bunch of data coming out. So there's plenty of blank data, which is not that great. So you see we have like lots of data. Oops. So here you see, so basically what I've done is this one, I just format table, so it gives me a table. I can dump it to CSV. I start to size so that all the sizes the different things. So you see you've got this new table, you've got app ID, audio in timeline, audio out timeline, comp dirty, there's a whole bunch of new data that looks quite interesting. So right now we don't know what app it is, right? So we have the app IDs here, right? So I'm gonna pick one at random, 2102, because it's right in front of me. So here again, we have the power of PowerShell. I can just basically do my original DB ID dump, where my object, so I'm gonna look for ID index equals 2102. Then I'm gonna format table. So I know that, so these 3 lines are actually usage data for Microsoft Lock App, right? So that's one of the Windows apps. So my next step, probably next few weeks, is to actually script this automatically to be able to reassociate all the data across the different tables. So I can start pulling out fancy graphs in CSV. No, I don't want to restart. I have backup slides just in case. It's always good to have backup slides. So next steps, really it's about automating the data processing. I have to basically extract the Shrew ID data better. I need to pull the registry entries that I'm going to need to use. I'm investigating how to use PowerShell remotely. So you can actually use PowerShell remotely if you have WinRM typed built in. And build a module so I can actually do that command where I'm just dumping everything directly into memory. Problems I have is I need to do privilege escalation. There are PowerShell version implications. So if your organization hasn't been updating PowerShell, you might be in a too old version of PowerShell, so you only get version 1 or whatever. So you won't be able to access half the functions like the .NET APIs. So Windows servers, for some unknown reason, the Shrum database isn't there, but the diagnostic policy service is running. So I have to figure that one out. And nobody, it's not, again, not documented. It's like, thank you, Windows. And there's a whole bunch of other stuff probably, but then this. So I beta tested this presentation. I said in Security a few weeks ago, one of the guys at the university took it, started playing with it, and he found out it couldn't find anything. Didn't find anything useful. There was only 1 month's worth of data. What was it, 2 years ago? I think it was out of Germany. Basically, Windows had to reverse this whole mechanism and throttle it because of privacy concerns. And that's just, it's a personal joke between a friend of me and mine. It's an actual keychain I have because I do a lot of GDPR work as well. So that's basically where I am with that one. But so what about the hunting aspect? Well, if I think about the initial investigation, I've basically got usage, network. That's good for user activity, right? So I can start looking at hunting based on that user activity. If I have my tools and I can do it dynamically, I can start doing that hunting. Now, if I add finding files, finding hashes, because yes, with PowerShell, I can do hashes dynamically on files. So I can do file IOC searches. I can search Windows events, right? I heard Florian's name mentioned a few times. He's got a crap load of databases with Windows events that you need to look for. You can dump configurations and access WMI, which, if you think about it, these costly tools and this open source tools, what the hell are they doing? They're just doing this. So why should I deploy one of these tools when I can just do it with PowerShell built in? And that's how I came to this conclusion, and that's how I came to this work that I've been doing for the past few months that is getting nowhere because of work, my real work. I have to pay the bills somehow. So that's me. Thank you very much for listening.